Good afternoon. Thanks for coming to Demo Day 5 and to our panel on the dawn of the robot age. Here at SparkLabs, our mission is to select and then help grow or raise, as Hanju said, the next generation of entrepreneurs, CEOs, and their companies. And that's what this Demo Day is all about. But it's also about content, bringing in thought leaders from around the world to educate us, to inform us, to inspire us. And so we've brought 3 distinguished robotics experts in from different parts of the world. I'll introduce them in a moment. Let me just set the stage and context here first. So what could be more exciting and more relevant in today's world than the topic of robotics? There's been a lot of changes, cheaper sensors, faster processors, and you're seeing a lot of robotic applications, not only in the traditional world of manufacturing, but now robots have come out into all aspects of our life. And in fact, we have a diversity of applications here. Here in South Korea, how many people know about this, the robots in the DMZ? South Korea has Sentry robots now in the DMZ. They're made by a division of Samsung, cost $200,000 each, and they can see 2.5 miles, they can shoot machine guns, and they can launch grenades. So this is South Korea's way of reducing its costs for the DMZ and reducing the risk of life. Here in South Korea, we also, just last week, it was announced that Alibaba and Foxconn are investing in Softbank, the Softbank Holdings robotics company, showing the importance of the Chinese, Korean, and Japanese markets. And one final Korean robotics note. In California 2 weeks ago, the Korean team won the DARPA Robotics Challenge. But all the stuff happening in robotics, it's happening around the world. And so we've brought these 3 distinguished guests. We have Patrick Tresset, who's in from London. We have Ian Bernstein from Colorado, and Andra Keay from California by way of Sydney. So each of them has a particular specialty. Patrick Tresset is an artist who drew portraits, and now he's gone into robotic art. He's created robotics that mimic his drawing style, and he's also putting on exhibitions at art shows. We have Ian Bernstein, who's been creating robots since he was 12, the founder of Sphero, and he's going to show you a couple of the connected toys, connected experiences that his company is creating. Very, very cool. They just announced another $45 million of funding a couple months ago. And finally, we have Andra Keay, who's, I think, the busiest woman in robotics. She is involved in at least 4 different robot-related companies, including Silicon Valley Robotics. She's an evangelist for robotics and puts on a lot of events, brings together people, is very, very aware of everything going on in the world today. So without further ado, I figured we could start our actual panel. Now it's up to our distinguished guests to provide the content. I'm going to start you off with an easy question and sort of an introductory question for our audience here. If each of you can just take 90 seconds to tell everyone about what you're up to, 90 to 120 seconds, a quick introduction, that would be very helpful. Patrick, do you want to start?
Hello to everybody. It's quite a coincidence, but at the moment I'm showing one of my installations at the Museum of Contemporary Art in Seoul. So you can see my work there. In general, I exhibit robots in museums, and those robots draw people, and it's my specialty. I also work in the domain in research in computational creativity, where we try to use artificial intelligence and apply it to creative activities. That's mainly my different activities at the moment.
Thank you. Ian?
All right, like Carl said, I've been building robots since I was 12 years old. About 5 years ago, I had the opportunity to start this company, Sphero, a robotics company where we focus on the experience. And we're starting to build robots with mostly like the fun and entertainment first, rather than utility. So we're in about 70 countries now, 10,000 retail stores worldwide for our 2 products that are out. Sphero is our first product. It's this little robot ball that connects over Bluetooth to your smartphone. And you can download different apps and play different games, and you can program it. Ollie is our second product that came out last year. This thing goes like 7 meters a second. It's all about crazy driving and tricks. And if you guys have seen the new Star Wars trailer, Episode 7, the BB-8 robot, we had the opportunity to work with Lucas on bringing that BB-8 robot to life as a toy. So that's something we're working on right now, and it'll be out later this year.
And I've been involved in helping robotics get into the real world, because for most of my life it's been science fiction or stuck in the research lab. And I really felt that we were at a tipping point. And when I moved to Silicon Valley 5 years ago, we were just at the start of the point where a lot of interesting robotics was starting to come out of research. And commercializing robotics is not necessarily easy. Something Rodney Brooks says is that robotics is less about a technology problem these days and more about a business problem. And I quite agree. Silicon Valley Robotics acts like an accelerator. We do a lot of things to try and help robotics companies get funded, and sometimes that means helping them get better at having good business models. And we're starting to see more pragmatic, more kind of consumer-facing robotics, and that's pretty exciting.
Thank you. So just building on that answer, as I stated, we've seen robots come out of just manufacturing into all sorts of different applications. I have a question for all three of you, any that care to ask. Which sector do you find most exciting now, and which advances have made that more possible?
I'll dive straight in and say agriculture. I actually really like the robotics that happens where most of us don't see it. But agriculture is amazing because we're starting to, and we needed to solve some really big problems, mainly conformable gripping, soft robotics, the ability to handle things without hurting them. And we're just starting to see soft robotics grippers be commercialized. And that means that we can handle objects with unusual shapes and dynamic shapes, things like fruit and food, or even animals. And you know, did anyone know that there are dairy farms that operate without people, just cows and robots? Yeah, I find that fascinating. The fact cows actually are really good at operating robots, better than us.
Sounds like a future science fiction movie, cows and robots. Patrick or Ian, do you want to weigh in?
Recently, I've been quite interested in Android robots that look like humans, but I still haven't been convinced by what is. But I think there's a lot of potential in that in the future.
I guess for me, like, definitely consumer robotics is definitely the most interesting, because we want to put robots in everybody's home, and you can, I mean, it'll happen at some point. Like, no doubt about it, there will be a robot in everybody's home at some point in the future. So that's something we're going towards, and it's really cool, really exciting time right now, just with the sensors and things that they're putting inside smartphones. The cost is coming down on the physical hardware, and then on the software side, I mean, there's amazing software tools that robotics companies can now use, like Siri and Google's speech recognition and things like that, natural speech recognition, that is awesome for robotics companies.
Great. So building on that, obviously robotics is something that combines software that is often artificially intelligent, and then it combines the actual physical hardware, you know, hydraulics and moving parts and so on. As we're here for a demo day and accelerator, you know, obviously when you have hardware companies, it takes a lot more capital to produce your product than just a software company. The cost of creating a company has been going way down. And so I wanted to know, you know, Ian, you may answer this a little bit differently because you actually are manufacturing on a bigger scale, but I wanted to know from the two of you here, your perspective on how much the hardware cost has impacted you or your business plan and or your investment. Patrick, similar for you on a smaller scale, and Andra, maybe you can answer the same question with respect to your perspective across the different companies that you've observed, the trends in the industry. Does that make sense?
It does, and look, I'll start backwards then and say it's not always the prototyping that's the problem these days. I think that's become significantly more affordable and achievable. And I think with all of these things, hardware or software, it's always a question of scale. If you're doing something that's enterprise scale, it's expensive. If you're doing something that's consumer scale, it has to be a lot cheaper. But where people in robotics hit a little bit of a hurdle is raising their first post-seed round, when investors are looking for more proof of traction, and you need to have more than a prototype quite often to be getting that sort of level of proof of your concept. And so sometimes that can be a bit of a sticking point.
And Ian, it's with Sphero, obviously you've raised some rather large rounds, and part of that probably is the capital needs for scaling up a physical product. How did that affect your strategy for raising capital along the way?
Yeah, I mean, obviously for a hardware company, I mean, for instance, like when we started, we went through Techstars in 2010, the accelerator in Boulder, Colorado, and basically at the time, Techstars gave us like $6,000 per founder. So there's two of us that started the company. We ended up running out of money like halfway through the program because we were making hardware and having to buy circuit boards. And I think we're the first hardware company to go through Techstars. But yeah, obviously as we scale, like, I mean, logistically, it's really hard with lead times on parts and having to purchase things months and months in advance, and then not seeing that come back for 6 months. It's obviously a huge logistical challenge that obviously, you know, we're fortunate enough to have some good people on our team that work on that. But yeah, it is definitely hard for a robotics company.
Now, Techstars have actually changed their program, and they've just opened a robotics accelerator. They've expanded to 4 months from a 3-month program, and they're offering between 28,000 and 128,000. So they're really cognizant of the fact that you need to be supportive when it comes to hardware prototyping, and that can smooth things incredibly.
Indeed, and Patrick, you've had the same issue. I mean, even though you're a visiting professor and doctoral scholar and artist, you still need to act like an entrepreneur and raise money through grants and other ways to, you know, how have you tackled the hardware challenge? Has that been limiting in what you've been doing as an artist and a computer scientist?
Well, yeah, it's true. I'm working more like a craftsman in terms of scale compared to you. So, I mean, I'm only building 20 units or something like that. So still, because I'm on my own, I need to find things that are fairly low cost. So I use actually a Korean company, Robotics, as a manufacturer for the servos I use. And it's very helpful. I mean, I think that because the cost has gone down of hardware, it enables for hobby researchers, which were so important in developing the PC market in some way. All the research into PC software was done by individuals, mainly at the beginning, because the cost was so low. And I think we are in the same situation now.
Great. Patrick, I have a follow-on question for you. What we didn't really have time to tell the audience is that your research, you've created software that basically mimics the way that you used to draw personally with shading and so on to some degree. And I wanted to ask you, have you found the best success on the software programming side with algorithmic approaches, or is it more pattern-based, pattern matching?
Well, there are two answers. You all know that robots are quite difficult. They need to be as simple as possible to work. So because I exhibit in museums and they interact with the public, they are as simple as possible, so it's more algorithmic approach. But in my studio, in research, I use more pattern-based, so more experimental things. It's always a problem. I do research in my studio, which is quite advanced, but it takes a very long time to get into the exhibition stage.
Great, thank you. So we've only got a few minutes left on the panel. One of our panelists is actually catching a plane, but I wanted to open up to the audience. Does anybody have a question that you want to ask our distinguished guests? Yes.
They're not autonomous, are they? Their ability to hit the target is not autonomous. It's actually controlled by a person.
That's correct. I don't know if you could all hear the question, but the question was the SGR1 Sentry robots in the DMZ, are they autonomous or not? Right now they're under, I'll just answer that one myself, they're under human control. So yeah, they're not fully self-managed at this point. They report back. If they notice a target, a human being with their infrared sensors, they report back to human commanders, and it takes a human to actually tell them to shoot or launch a grenade and so on.
I think that's the reality of robotics, is that you're going to see humans in the loop, as we call it. We're working on getting better and better autonomy at low-level tasks, but we still really need to have a lot of human control in higher-level tasks. And did anybody actually watch the DARPA Robotics Challenge a couple of weeks ago? Has anybody seen the video of Korea's team that won the competition? Because that was an amazing performance. They completed 8 really difficult tasks from a disaster response scenario, and they did it in less than 45 minutes, which, the thing is, a human could have done those tasks in 5 minutes, assuming a human could have survived in the environment. And the idea is that we need to start to get better quality robots that can contribute usefully in something like a disaster response scenario. And these robots were partly teleoperated, but they were partly autonomous. And one of the issues when they went inside the simulated disaster environment is that they lost communications. So it was more challenging than it looked like on the surface. And if you haven't seen it, it was a fantastic job from Korea, so you should watch that video.
This leads me to one more follow-on question actually for Ian. Part of the reason, Ian, that I didn't ask you a similar question about your algorithms with intelligence is that you also have human operators with Sphero and Ollie. It could be kids playing with toys. You've built in sort of the robotic functionality, but most of the controls done through applications where you have a whole universe. People can create applications for your platform, and then of course it's human controlled as well. Do you want to talk about that just a little bit, the autonomous control, and how that made it simpler to develop these connected toys?
Sure. I mean, I guess for our product, it's sort of like a car, right? Like analog brakes and stuff like that. So we, on the screen of the app, you push the joystick in the direction you want Sphero to move, and then we do tons and tons and tons of math to figure out how to actually make that happen. On the programming side, yeah, Sphero is as open as we could make it. So you can program in 15 different languages. It's used in about 25 different schools right now, 2,500, teaching kids like art and programming and physics and all kinds of different stuff. It was always something, a passion of my co-founder and I, are sort of hackers and makers, and we wanted our product to be as hackable as we can make it.
Great, so I think we have time for one more question from the audience if somebody wants to ask one. Sir?
Hi, I'm John, and I want to ask about artificial intelligence. It's kind of a big topic, but since there are many sci-fi movies about Chappie or Avengers Ultron, the kind of thing, so do you guys ever afraid about when the artificial intelligence get onto the robots? Like, is there any kind of safety to switch to turn off?
Do watch the DARPA Robotics Challenge, because the standing joke at the DRC is we have no need to fear the robot apocalypse. We just need to keep the doors closed. Okay,
Yeah.
So maybe I'm scared about AI, but not in robots. It's AI in everything else that worries me.
It is a little scary, though. I mean, I did watch Chappie on the flight over here. So, yeah, I mean, there's definitely like physical limitations with batteries and motors and things like that. But I've been to like conferences in the past, like talking about the singularity, and the singularity happens when we develop a computer that is more intelligent than people. And it seems like that's going to happen. I mean, it might be, there's theories about when it'll happen. It could be 50 years, 100 years, 1,000 years, but it seems likely that it will happen at some point. And when those sort of intelligent computers that are smarter than people get into machines, it is a little scary.
Yeah.
Final comments?
Yeah, well, I think that, as usual, the problem is not especially the robots or the machines. The problem is with the humans. The humans are the dangerous ones. And we just tell the machines to do naughty things. I think it's always the same problem.
Indeed, well, we appreciate your attention and your questions, and maybe you can give a round of applause for a distinguished guest that traveled a long ways to get here. Thank you.